All right, so we're here to talk about the DuroVac Core Central Vacuum System. This is the epitome of all of our design and engineering when you have the requirement for a fixed central industrial vacuum system. So let's focus in on these keywords. Fixed means the likelihood is this vacuum system that you're going to be acquiring from DuroVac is bolted to the ground. So you're not moving it anywhere. It's fixed. What does central mean? Central means that it's a system that is in a fixed position that powers your operations in terms of vacuum in a centralized way. And other keywords are industrial. We want to make sure that we are always repeating to all of our audience out there, these are vacuum systems that are built like tanks, that are famously tough, that are here to answer to industrial applications. It can be simplified or it can be very complex, but just know that the core central vacuum system will get you what your heart desires in terms of your process or your operations. So how do we start? The first thing we do when we want to make a system selection for a core central vacuum system is we want to know what you're moving, your materials. Your materials will encompass a lot of characteristics from its density, its hygroscopy, its flowability, etc., etc., etc. So it's very important when you're contacting DuroVac that you know this about your application. What are the materials that are being moved? Are you moving sand? Are you moving feathers? Are you moving corn? Or are you moving golf balls? So all of these are really important for us to know because it will help us get through the first step, which is selecting the right vacuum package. So what kind of airflow and vacuum do we need? Second, what do we need? Well, how much of it are we moving? Are we talking about a bag of marbles? Are we talking about a truck full of marbles? Are we talking about a production floor that is 200 by 200 buried in corn? Or are we talking about a couple cans of corn? So really important for us to know the volume of material we're trying to move in an instant of time. So are we trying to convey 200 pounds a minute, 10 tons an hour, or 50 pounds per hour? Completely different animal, things that we must know. Third, we need to know how far we're moving it. So there's a difference between moving a bag of marbles from here to there. If it was from here to there, I'd do it myself. But if we're trying to move it from here to the end of my plant that is 500 foot long, that's where we need to make some calculations to make sure we have enough airflow and enough vacuum to take us there. All the other questions now are starting to relate to accessories and features. Where do you want to position the vacuum system? Is it indoors or outdoors? This has an impact whether your material is combustible or not. That also has an impact on whether you want to reuse the air, because air within the vacuum system gets compressed and heated up, so you might lose this kind of heating factor. Also, what do you want to do with the materials? Do you want to dump it? Do you want to put it to waste? Or do you actually want to reprocess it? So do you want to retain the material and discharge into another process where it can go right back into your plant and get revalued? Important question for us to answer. And lastly, since this is a fixed, centralized industrial vacuum system, you can either use it with one user all the way up to 13 or 13 and beyond. In our product line, you will get a quote for up to 13 simultaneous operator or concurrent user fixed central vacuum system. You'll get that quote in about 30 to 50 minutes. If you exceed that number of users, it's absolutely doable. We've done it before. It's just it starts getting into the realm of engineering that is a little bit more customized. Okay, so with all of these questions and these parameters, now we can start sizing up your system. When you've got your material, what your material is in its density tells us what kind of airflow, starts telling us what kind of airflow and what kind of vacuum we need to move it. Once we've got the distance, we can calculate the velocity, pressure, and the energy required per increments of 100 foot to move it from point A to point B. So these are all critical design parameters that we feed into our software, and it spits out the right answer for us. Then we've got a whole set of engineers, whether it's technical sales engineers or engineering doing drawings and documents that will help validate that is in fact the right solution. Great, we've got your design parameters, your materials, and then we're starting to crunch some numbers and run some mathematics, and we determine what kind of vacuum package do you need. The vacuum package is what we call the heart. It provides us an airflow, volume of air, and it provides us a pressure rating, a total pressure. So this allows you to move material with airflow and take it from point A to point B using vacuum. So that's the vacuum package. Whew, that's a lot to just get a vacuum package, just to get to the heart. Well, now that you've got a functioning heart, what are you gonna do with all those tons and tons of material that is coursing through your centralized network? Well, we need lungs to separate them and to filter them, because we can't get dust and materials through a pump. It will cause catastrophic damage. So this is where we match the vacuum package to the filter separator. We call it a filter separator because that device separates mechanically and filters mechanically the materials, and then ultimately discharges it into either a waste bin or another process. So, step one, we need your materials such that we can select the right vacuum package. Then we match the vacuum package to the correct filter separator. One may say, hey, how do we do that? Well, there are a few design parameters that we take from step one that are things such as material density, combustibility, flowability, hygroscopy. All of these things are important to us to make sure we make a good selection of a filter separator, as well as all of the accessories that go with it. From the discharge valve, you might need an oversized discharge valve if it is light and moderately light density materials, or if it's ultra abrasive stuff, we might need a double flat gate valve. Finally, one of the key accessories that we put on a filter separator in today's knowledge is 65% and beyond of materials are combustible. So we must protect all of our equipment with NFPA compliant explosion vents, flameless vents, or even sometimes chemical suppression. And we may go as far as to recommend not to use a vacuum system on certain very explosive materials. And we will also have other accessories such as inlet isolation valves, fast acting valves, infrared detection type of fast reacting systems depending on your material type. So it's very important that you tell us what your materials are. So we've got the vacuum package, we've got the filter separator, and one of the other accessories that the filter separator sits on is its frame, its structure. We have pre-designed and pre-configured structural stands and service access available at the fingertips. Now you may choose, because this is industrial equipment, to fit it within your own plant, maybe on the third floor, right above a reprocessing tank. Fantastic. We'll provide you the drawings and we'll make sure that we do all of the integration engineering such that it fits in your plant. Now, controls and instruments. This is where it gets fun at DuroVac. We covered a segment where the power lift and the elevators already has two pre-engineered control panel sizes. Luckily, a lot of the features that are built into the power lift and the elevator do exist in the core central vacuum system series. And so we've taken all of that design know-how and applied it to these fixed central vacuum system control panels. If ever we need to move outside of that gamut of capabilities, once again, we'll build in the engineering time to make sure that we have all of the controls and all of the complexities that are required to based on your plant operations. So what could those be that are outside the standard? Special VFDs, PLC controls, special transmitters and control points that may be governed within your plant operations. So just bring those to the table when you're speaking to your DuroVac representative, and we'll make sure that we clearly identify what is standard at DuroVac and what is outside our standard, that which we can customize the system to. If the PowerLift DVR, DVP, and EL series has almost 15,000 permutations, one can imagine how many permutations the core central vacuum system has. Well, I'll be able to tell you it's close to 40,000 permutations just because of all of the components and the features and instruments that it has. We will use your design parameters, our selection software, and make sure that we configure your system to your application. Typically, somewhere between about $75,000 in budget to get started, all the way up to sometimes $500,000 depending on the complexity of the system. Now that's a wide range, so that's why it's important that you come with your design parameters, speak to an expert at DuroVac, and we can really narrow down that budget.